Let's go through LeetCode 3226. Number of bits changed to make two integer equal. For this question, it give us integer n and k. And you can choose any bits in binary representation of n that equals to 1 and change it to 0. Return the normal change, you need to make n equals to k. If impossible, return -1. So we can, for example, there is one, for example, this n, right? It may be 1 0 1 1 1 0 and k, right? For example, it is 1 0 1 1 0 1, right? So in order n change to k, right? We can only change nth one bit to k, right? To k to 0, right? When it is k, n is 1 on this bit. So we can change this to 0, but we cannot change this, right? So in this case, n cannot change to k, right? So if there is any bits on n that is 0, but on k that is 1, we should return -1, right? So we can do iterate bit by bit. Use for every I equals 0, I smaller to 32, right? And to check the bits, right? For we can have the n right shift 1 and use n 1, right, to get those kind of the I bits from the Lewis bits, right? In that case, if we compare one by one, that we do is that if this value equals 1 and this value equals to 0, right, then we have a result plus plus. And in case this one equals 0 and then this equals 1, then we'll return -1, right? So we can use a for loop to iterate every bit from 0 to 32, right? If we use a while loop, we should use while n doesn't equal to 0, right? Or k doesn't equal to 0, right? To have n right shift 1, right? And k right shift 1. So let's write code for this. So let's write it's a for loop. So we'll have int result equals to 0, right? So for int I equals 0, I smaller than 32, I plus plus, and we're going to have so let's say if n and 1 equals 1, right? And k and 1 equals to 0, right? So like this, what we are going to do is that we're going to have results, increase the result. Let's say if this kind of n and 1 equals to 0, let's say, and k and 1 equals 1, right? So we just return -1 in the end, return result, right? Every time we should have n right shift 1, right? And also k right shift 1, right? we can also use first check if K, right, is n subset. So that is if that means if we can convert some of the nth one bit to 0 to be K, right? So K should be a subset of n, right? So K should be a subset of K. And so that we should have n. We know to check whether K is a subset of n, that is n and K should equals K, right? So if it's not equals to K, we just return -1. If it is subset, then what we do is that we just need to use XOR, right, to get this one as 0, then count the rest once, right? So we can write another formula that is if K and n, right? If this one doesn't equals to K, that means K is not a subset of n. That means n there is some kind of bits K is 1, but n is 0, right? In this case, we're going to return -1. And else, what we do is that we need to count the 1 bits for K XOR K, right? And so let's have int v equals K XOR v, right? To check how many 1 bits in v, right? So we'll say for int I equals v, right? I constant equal to 0. V I equals v and v -1, right? So in this case, we're going to have result 0, right? To count the 1 bits, so have a result should increase, right? And in the end, return result. Right. Equals oh, sorry, this is not I should is this, right? I and equal to I -1, right? Otherwise I will never change, right? So change this to Python code, right? Python code should be similar. So let's say if n and K doesn't equal to K, right? Then we return -1, right? Otherwise, we just calculate this kind of V bits, right? In XOR K, right? So we have result equals to 0. Well, we can have while loop while V doesn't equal to 0, right? And V XOR equal to V -1, right? We'll have result should plus equal to 1. In the end, we just return result.